your reporter for today, and I am Marinalyn P. Basan. So, before I start, I have something facts about mathematics. So, what is it? So, do you know that the father of mathematics is Archimedes? So, let's go back to our topic. Our topic for today is all about circular functions on real numbers. Archimedes was a Greek mathematician, physicist, engineer, inventor, and also astronomer. Although few details of his life are known, he is regarded as one of the leading scientists in classical antiquity, considered to be the greatest mathematicians of ancient history and one of the greatest of all time. He is born on 288 BC in Syracuse, Italy, and he died on 212 BC, Syracuse, Italy. His full name is Archimedes of Syracuse. His nationality is Greek. So let's go back to our topic. Our topic for today is all about circular functions on real numbers. We define the six trigonometric functions in such a way that the domain of each function is a set of angles in standard position. The angles are measured either in degrees or radians. In this lesson, we will modify this trigonometric function so that the domain will be real numbers rather than the set of angles. So recall that the sine and cosine functions of angles measuring between 0 degree and 90 degree were defined in the last quarter of grade 9 as ratios of sides of a triangle. It can be verified that these definitions are special cases of following definitions.
Let theta be an angle in standard position and p theta will be p of x and y. The point on its terminal side on the unit circle. So here are the six trigonometric functions that we are going to use in this section. Some of them we are probably familiar with, and some of them are probably a little bit of confusing and still are fresher to us. Now, first of all, we are going to define sine theta as y. That means the sine of a real number is equal to the y point in the terminal point. So remember that our terminal point is p, x, and y. So now, similarly, we have cosine of theta, which is going to be defined as the x-coordinate of the terminal point. And tangent of theta is defined as the ratio between y and x. Note that x should not be equal to 0. Now the fourth one, we have the cosecant of theta, and this is going to be equal to 1 over y. And again, y should not be equal to 0. The next one is called secant of theta. Yeah, secant of theta. This is defined as 1 over x. And make sure again that x should not be equal to 0. Finally, we have cotangent of theta. This is similar to tangent, but it's gonna be x over y instead of y over x. So again, note that y should not be equal to 0.
Let's take a look for the example that I have written here as well. So we're going to find the values of sine and cosine for t equals pi over 6. This is the terminal p by the real number of t. So sine is equals to 1/2. And cosine phi over 6 is equals to square root of 3 over 2.
If you don't wanna see me, did a full 180, crazy, thinking about the way